In this episode of the AWS Developers Podcast, we're talking about deploying Jupyter Hubs on Amazon EKS, Elastic Kubernetes Services. Good morning, good afternoon. Thank you for downloading the AWS Developers Podcast in whatever country you are, whatever geographical time zone you are. Every Friday, you have a new episode in all your podcast applications, Apple, Spotify, Amazon Music, YouTube, and all the other podcast applications as well. We are recording this episode from the AWS Summit in Bengaluru, in Bangalore, in English, in India. I'm with Tiffany. Thank you, Tiffany, for traveling to India to record episode of the podcast. And today we have an AWS community builder as a guest. Hello, Hadith Moody, your community builder, your solution architect. I think you're also one of the few that has the golden jacket.
Yeah, that's true. Hi everyone.
So golden jacket means you reach 12 AWS certification.
That is correct. I have 12 active AWS certifications.
12 active AWS certification. A few months ago, we had an episode with one of your colleagues, Code, that also has the golden jacket. Ivan Casco is also a community builder based in Dublin, if I remember correctly. So if you want to learn more about this famous golden jacket and the 12 AWS certification, go back in time and listen to the episode from May this year, episode number 165, I think. I don't have my notes in front of me. But we are not here to talk about certification. We are here to talk about Jupyter Hub and your deployment, the deployment that you did on EKS. Maybe just to allow developers that are not familiar with the data and AI world in a very short paragraph, what would be, how would you describe Jupyter? What is a notebook?
Yeah, that's a really interesting question, right? Because when we work with customers, we generally see a lot of data science people. And data science people, the favorite tool for them is Jupyter Notebooks, right? Now, Jupyter Notebooks is nothing but a coding environment for data science people, data scientists, ML engineers, and some analysts, right? All of them use Jupyter Notebooks for for building data sets, right? So they want to deploy a data set, they want to build or train a model, and they want to visualize the results, right? And all of this is possible with Jupyter Notebooks. So Jupyter Notebooks helps you to use the AWS or any cloud provider for that matter to use a compute for them, and then you can just try and build the data using models, deploy them, and visualize results, as well as you get some good documentation as well.
As a developer, I love notebooks because I can type my Python code there. It's like, maybe you saw that already. It's a web page. You can type your Python code, hit run, and it runs, it executes. You directly see the result. You can iterate really quickly. It's also a good way to share your knowledge because you can put comments in Markdown text. So if you want to deliver a workshop or something like that, or a training class, it's a very convenient environment. And you're deploying that in an enterprise at large scale for hundreds of people?
Correct. That's correct. So I would just want to walk backwards and just try and give the audience a sense of what the problem statement really is here, right? So we're working with a customer of ours who's probably has a large data science team. So they probably have a lot of data science engineers or data scientists, right, working on a couple of projects. Now, the team is probably close to 100 people, and it's growing, right? Now, initially, when they begin deployments, they're trying to see if Jupyter Notebook works on a single instance, or probably Jupyter Notebooks locally, right? That's a good approach to start with because you are a small team. You don't want to experiment and go overboard, right? So that was a good starting point for them. But they quickly realized that using Jupyter Hub, Jupyter Notebooks on a single instance doesn't work, right? So they tried and went on to Jupyter Hub. Now, Jupyter Hub is a multi-user application or platform for multiple users to use Jupyter Notebooks, right?
So what's the main difference with a single notebook and Jupyter Hub for multiple users? It's a way to distribute the task across a cluster. It's maybe user authentication permissions.
Yeah. So the main advantage that you get with Jupyter Hub is that you get multiple users can have their separate logins, and the data resides separately. So it's kind of a multi-tenancy for the different users that are there. And apart from getting that, they also get some security benefits, because when you create and use a Jupyter Hub, you're probably adding a lot of security features to your applications. A custom domain.
Domain like in Active Directory domain or domain?
Not in Active Directory sense. Domain in largely our domain language, right? So you create a custom domain, something like notebook.company.com, something like that. So that's possible with Jupyter Hub. Once you have that, then you can have different logins that you can use with different providers, something like an Active Directory, something else. So it's really giving you a holistic platform for using for multiple users to use Jupyter notebooks, and each user can have their own separate notebooks which they can work with, and the data also is segregated, right? So it's really cool to use Jupyter Hub.
Yes. So it's really interesting for you as a collaborative platform.
Correct.
Okay.
Yep.
And one very naive question: there are managed notebooks on Amazon SageMaker. So why you cannot give access to SageMaker to the team?
Yeah, that's a really good question. So now, when it comes to you having a Jupyter Hub on a normal EC2 instance, here the problem arises that once the team increases, the size of the team increases, you will reach into a data or a scalability issue because your users are increasing. You cannot go above the particular instance type. You always have to keep increasing the instance type, which is not feasible for you in the longer run. So you'll probably be thinking, what options do I have when it comes to deploying an EC2 or deploying a Jupyter Hub on an AWS, right? Can I go with something like an EC? So I already have an EC2. Can I go with something like a ECS? Can I go with something like an EKS? Or can I maybe use SageMaker, right? So yes, we did face this issue. We initially were trying to understand what works, what doesn't work. So the problem with SageMaker is SageMaker is good when you want to train your models, and it also has a lot of good integrations. But our problem was we had custom libraries that we wanted to integrate. We wanted to add a lot of our custom logic, as well as we wanted it to be GPU based. So we wanted a lot of the GPU to be used for our different developers and different applications, so to say. So for that use case, we felt SageMaker wouldn't be a good approach. And then once we narrowed out that, okay, let's say SageMaker doesn't work for us, we did have the option of using Elastic Container Service or ECS. But again, the problem there is how do you ensure that whenever there is a scale, right? So whenever there is the number of users increases, how do you ensure that your user doesn't have to wait for the node to spin up and be readily available to them, right? So we are running into some memory issues when we tried ECS. I know ECS is really good, but when it comes to large-scale applications and using a lot of processing, then probably EKS or Elastic Container Service would probably be the right option.
So you choose Kubernetes, and in your team, you already had experience of deploying application on Kubernetes and managing Kubernetes clusters?
Yeah, that is correct. We went ahead with Elastic Kubernetes Service or EKS, and we did have a lot of experience in our team for deploying workloads to Kubernetes. So that was a good segue. So our teams were working already with Kubernetes and EKS, so it was good for them to be experienced in that.
And at what scale do you work? Like, how many people usually collaborate with the same notebook at the same time? Or what's the highest peak, that you can experience?
So, when it comes to scale, right? A lot of so we have 100 to 120 concurrent users who are using the Jupyter Hub application at a given point in time. So 100 user would look like each user has his own Jupyter notebook and he's trying to make a build or deploy a model, or maybe just analyze something in the Jupyter notebook, right? So when it comes to scale, we pretty much see a lot of GPUs and CPUs being deployed. So during a peak, it's crazy.
I went to the Jupyter Hub webpage when preparing this episode, and I see they have a Docker container ready to deploy. So what's the type of project, what type of planification preparation you need to deploy Jupyter Hub on EKS at scale, at your scale?
That's a really good question. And I must say, there is something that I want to give a shout out to. That is the data on EKS team. So data on
some data on EKS.
Data on EKS is something that the AWS solution library team built. So AWS has solution architects. You probably guys would be more familiar about them. So they build some solutions that help customers like us or partners like us for our customers, right? So they have built this repository called Data on EKS. Now, what this repository essentially contains is there is a lot of different solutions that are built. All of them are built using the AWS best practices. All of them have IAC or infrastructure as code with Terraform, with Cloud Development Kit readily available. So it is probably, you can say it's like a plug and play model. So what used to take you probably weeks to create and deploy. So for me, if I have to deploy a containerized Jupyter Hub on EKS using AWS best practices and using IAC, it would probably take me weeks, right? But if you have data on EKS, it did take us about a few days, right? Just to get everything to work, and all using AWS best practices. So it's pretty cool. And shout out to the team that's working really hard on this, and they are developing some good solutions and helping a lot of customers and partners like us.
And the link to the GitHub repo is on the notes of this podcast. So you scroll in your podcast app and you will find the link to data on EKS.
It's all open source.
It's on open source. Yeah, that's all open source. So what else is part of your technical deployment? We talk about EKS to have a managed version of Kubernetes. We talk about choosing Jupyter Hub as a start. Data on EKS to easily deploy Jupyter Hub on EKS. What else?
So one of the interesting things that we built with this application for our customer is our customer wanted to keep everything private, right? They didn't want anyone outside the network to be able to access it. Even if there is an authentication layer, they didn't want it to be able to be accessed, right? So one of the first things that we had to do was we had to set up a VPN. So we use BigIP. BigIP is a VPN provider to set up a VPN for their users, developers, right? So each developer has to access or get access via VPN. Once they have access via VPN, then it's probably easier for them to use the application. Now,
so we are talking about internal user from the company. Just internal,
correct. Internal users, developers who want to access this Jupyter Hub application, they can only access it if they are logged in via the VPN.
Okay.
So it's actually everything's private. Now, once you have done the VPN thing, you'll probably get access to the application. So you'll probably get the URL. So let's go in a workflow manner. I am a data scientist. I probably have access to a link. I'll probably click on that link or just browse it, and I'll probably not get it because I'm not logged in via VPN. I'll log in via VPN. I'll probably get the link. Now the next step is the user goes to the link. The link is basically nothing but a custom domain, right? It's probably notebook.company.com, and he'll probably click on it. He'll then be redirected to a network load balancer. So now network load balancer is then integrated with an authentication layer. This authentication layer is set up with Azure Active Directory. Now Azure Active Directory, there might be a question, why did we go with an Azure Active Directory?
That's exactly what we were asking ourselves while preparing this podcast. Why Azure?
Yeah, so the customer that we are working with already had an Azure Active Directory for their users, and we didn't want to go with another authentication layer on top of it. We wanted to keep it simple, and all the users that are already part of that Active Directory would easily be integrated because of the application that Jupyter Hub has and the easy integration of an authentication layer, right? So it's very easy to integrate an authentication into the application of Jupyter Hub. So
that's part of the configuration of Jupyter Hub. So you don't have to write your own login page to the AD.
So you can easily integrate Azure Active Directory with Jupyter Hub. And as I was mentioning, first you need to do a custom domain thing because it's essential to have a custom domain. Once you've done that, then you have to authenticate it using an authentication layer, Azure Active Directory in our case. Once that is done, you'll probably have access to the Jupyter notebooks. So each user, once he's logged in, has an access to their own Jupyter notebook.
They can choose the instance type or depending on the work they have to do.
Correct. They have to choose an instance type depending on the work they want to do. It's data around. They'll use some CPUs, something CPU around. Right. So it probably depends on the user and how he wants to use the particular Jupyter notebook.
You said that many of your users needs a GPU to run their code or to run their experiment there, and makes sense. So how do you manage that fleet of machine of EC2 with GPU? So what's your EC2 fleet looks like?
Yeah. The EC2 fleet is it has so we have a few GPUs and few CPUs for certain tasks, like from an application perspective. There might be some use cases where you might not want to use a GPU, right? Because they're not that intensive when it comes to a model. You're trying to train a model, it's intensive. But if you're just trying to do some analysis or some visualizations, it might not be that.
You don't need that.
Yeah. So those cases, we probably use some CPUs. But in other cases, we probably use GPUs. The two interesting things that I would want to highlight here. One is using a Carpenter, and two is having an EFS. So those are the two interesting things that I want to highlight, because
let's dive a bit on these two parts. The first one you mentioned, I didn't get it. So
Carpenter.
Oh, Carpenter. Yes, the open source tool for auto scaling. Yep. So how are you using Carpenter, and what's the benefit it brings to this project?
Yeah. So when it comes to deploying containerized applications on EKS, a simple cluster autoscaler is probably not going to cut it for you, because the different instance type that you probably want is at runtime. Carpenter gives you the flexibility of giving you the runtime, the instance type that you might want for that particular workload. So that is the flexibility you get with Carpenter. But a really interesting thing that we faced was when we tried to use Carpenter, we tried to use a Spot instance, right? Now, for people who are not aware about Spot instances, they are probably something that is not an on-demand. So you probably have to. It's cheaper, but it can go off at any time.
Yeah, the way I explain it, usually it's extra capacity that AWS has at a given moment in the data center, and we prefer to sell you that capacity at a reduced price, at a bargain price, rather than leave it unused in the data center. But there is a but, as you mentioned, AWS can take back the instance. If a customer that has reserved instance, for example, ask instance, we can shut down your instance, and you have 2 minutes to clean up and save your data.
You probably explained it much better than I could, but essentially, yes, that is the plot for using a Spot instance. Our thing was, how can we try and reduce the cost, right? So we tried and used Spot instances. The problem with Spot instances is when you're trying to use a Jupyter notebook, it usually takes some time for it to spin up. And Spot instances, we're going into some issues when it comes to Spot instances for some of the Jupyter notebooks. So the way we used Carpenter was we had two different provisions. We had a Spot instances and we had an on-demand instances. So for tasks which were relatively high memory and consumption, we probably wanted to use something like a compute on-demand thing, so that we are having nodes readily available and they can be used for the memory intensive tasks. But for tasks which are probably here and there, you might want to use them. Spot makes more sense, and we are able to cut down on cost because of using Spot instances.
So if it's managed by Carpenter, how does it know before running the cell that this is a job that will require, like something that is on demand or something that is, a Spot? Like how do you know before even like launching the notebook that how do you reroute? Like what are the
routines?
Yep. Interesting. Because for that we had to manually have configurations in place. So whenever there is so we had a switching kind of a functionality that we manually configured into our images. So whenever there is a resource intensive task, it is given a different configuration than a normal task. So you within your images you have to make that manual configuration, and within that configuration you have to add your instance type, which is going to be a spot or an on-demand thing. But yeah, that's something that we had to make tweak to in our image setup itself.
What are the challenges for GPU management?
So the two probably key problems that we faced when it comes to GPUs. One was there's a instance type called Trainium. It's not available in AP South 1, which is the region that we work with our customers in, right? So for us, we had to use another region to kind of suffice the requirements. So that's something that we face. Another one of the things is there are different users who are probably trying to use GPUs, right? Now, essentially, what we want to do is have a user use a bit of GPU, but at the same time, whatever's left of the GPU, someone else should also be able to use, which is the idea of GPU slicing, right? So you're trying to slice a GPU to be used by multiple users. So yeah, I think for us that was a bit of a challenge, because initially when we configured the Jupyter Hub using the data on EKS referenceable architecture, we didn't get that functionality. So when we tried, when a user was using a GPU, that was probably getting used by that user itself, and another user wasn't able to use that GPU. So that was a challenging thing. But then we did involve AWS teams for that. So AWS folks were kind enough to jump on a call, and then we did get some configurations to be done so that we're able to slice the GPU so that it could be used for multiple users.
So these days, generative AI is everywhere, and the flagship product for generative AI at AWS, or there are two actually. There is a Bedrock, Amazon Bedrock, and Q. Especially Q developer. I think you did some interesting integration between Q and the Jupyter Notebook.
Yeah. So definitely, like Q developer has really been something that our teams have been using from some time now, and it's really been transformative for us. To even write code, to just ask queries to a Q developer or Q console, right? So the problem here that our customer faced was they're having a Jupyter Hub, but what if they wanted to write a proper query, or probably write something which is according to the best practices, fits what Python script would look like, or maybe needed to write a script, maybe needed to debug a problem, right? So they had to go back and forth, because they had to come out of that VPN, because that's all private. They wanted to go to Stack Overflow, maybe ChatGPT. They just wanted to search and understand the problem, right? Now, what if there was a solution to this, right? And the interesting thing was, we said, hey, you can integrate Q into your Jupyter Hub application, right? It's that straightforward. You just have to maybe install Q into your Docker images, and once your Docker images are deployed, a Q logo console pops up on the right-hand side of your Jupyter Hub application, and you can pretty much chat with it with anything, right? You can ask it, I have this problem, can you help me fix it, right? And it will give you prompts, it will suggest things. It's really good for the data scientist.
So it's Q developer command line, CLI, that is installed on the machine or the Docker container where the notebook is running. Did I understand correctly? And then there is a nice user interface integration in the web app.
Correct. That is true.
Talking about new tools, there's also a new pen with the a SageMaker that we have announced recently at reInvent, which is the Unified Studio. Have you tried it? Is it something that kind of overlap with your tool? What's your thought about it?
It's an interesting question, because I was coming to it. So there is something that I wanted to mention as a future scope. What we are looking at in terms of developing after we're done with a lot of our things is how do we try and use SageMaker Unified Studio into our applications? And we're thinking that for development, it's probably Jupyter Hub makes sense for developer for data scientists. But what happens if there is a large training job, right, or large training model? You probably might want to also use and try and see if SageMaker Unified Studio might help you in that case. So there is some potential of using it in the near future, and we'll definitely try and experiment and see how our customer can leverage SageMaker Unified Studio to make better decisions when it comes to training large models.
So now that the solution is deployed into productions, what are the benefits you're observing for the business?
Yeah, so lots and lots of benefits, I guess.
Tell us about them.
Yeah. So earlier, there were a lot of bottlenecks because everything was on a single EC2 instance. Some point in time when there is a peak, people would run into memory issues. People would run into maybe some errors that they were getting within their Jupyter notebooks, right? Because there are multiple users using it and the capacity is not there, right? So you're running out of your GPUs and RAMs, right? So those are the issues, and using a containerized approach using EKS really solved it for us, and we are able to get a good concurrent users to use the application, as well as we are able to get persistent data storage with EFS, which is really important because users want the data to be readily available and persistent for whenever they want to access it, right?
So that's something already implemented right now. You have persistent storage on EFS, so that every time I restart, as a user, I restart a notebook, I can find my data sets that are still there.
Correct.
And the EFS file system are attached to the Docker container where is the notebook running.
Kubernetes EKS. So EFS is attached to your EKS clusters. Persistent volume planes. You use persistent volume planes to attach your elastic file storage with your clusters.
Yeah, EFS stands for Elastic File System. It's basically a managed NFS server, network file server. Going back to the benefits, the scalability, the performance, the storage, the shared storage in between.
The IAC aspect, right? We're forgetting the important thing here. Infrastructure as code. You're getting things done in probably days, right? And everything with AWS best practices. So it was like, so when this requirement came to us, they wanted to do it really quick, and we were able to do it really quick because we had the reference architecture and the reference code with us.
So what is the technology you choose for your IAC? Because there are so many between Terraform, CDK, CloudFormations, and many others.
So we probably went with Terraform because of our team's knowledge around Terraform. I'm myself an HashiCorp ambassador, so I'm pretty familiar with the Terraform.
Okay, so
Terraform, already aware about the Terraform ecosystem, the HashiCorp ecosystem. So yeah, Terraform is pretty familiar to me.
Now that you are there, what are the type of future evolution you're thinking about for the platform? So you mentioned already one. It's maybe integrating SageMaker Unified Studio that we just announced at reInvent last year, so a few months ago. What are the other things you're thinking about improving or making it even a better usage of the platform?
So one of the things that we didn't probably do is observability. So monitoring and logging is something that we're trying to integrate. So we're looking at some open source tools around Prometheus and Grafana that we're trying to integrate with our existing clusters, so that we get good visibility into how the application is performing. When is the peak? When is the not going to be that high of a scale? So all of those decisions and all of those information would be readily available to us. We're using AWS native tools, but we are trying to use open source more so that we get better access and better understanding of code.
For example, what are you saying in terms of open source tools?
Prometheus and Grafana.
These are the typical one to observe the workload on an EKS cluster.
Apart from that, we also have so for cost management or cost optimization, we're trying to see if we can use KubeCost. KubeCost is another tool which helps you with cost management. It looks at your cluster, it sees whether opportunities for optimization, and then it suggests those to you. So we're trying to integrate that as well.
What are the aspects you are the most happy about with this project, that the most satisfied?
Yeah. So one of the things that really satisfies me is when developers have a aha moment. So one of the
What is a haha moment?
aha moment is like you never saw this coming, right? There is something that you see and then you're like, oh, this is possible, right? So it's like an ecstasy for people, right? So yeah,
for example, when this haha moment, I call that the light bulb moment, when the eyes are opening. Wow. Yeah, so what was the haha moment that you observed with your internal customers?
So when we were working with the customer, they had some data scientists that were working with them, and this data scientists, they were facing problems and they were wanting to use some external tools. But when they saw a queue console and how they can interact with queue, they were like, oh, is it really possible to just mention a prompt and get a response to the question or the query, right? Can I just mention, hey, I want a Python script to get data sources from A, B, C locations, and it will really generate it for me? And I was like, yes, just go for it. And then probably they used it a couple of times, and then they were like, oh, this is possible, this is cool, right?
As it's kind of magical the first time.
Yeah.
We can see that.
Yeah, it's similar to the first time that we saw these AI models and we tried to interact with them, and we were like, oh, this is really cool, right? But in this day and age, it's like a lot of things are moving and a lot of new technologies are also being introduced, right?
Anything else?
Let me think. Yeah, there is one more thing. So the data on EKS is a really good resource for builders to use. So I would really encourage folks who are or people who are just listening to this podcast to really go out there and see the different AWS open source repositories that are being built. You will really find it to be valuable, and it will make your life easier because you can use this referenceable code repositories to create solutions, deploy the solutions, and then really get everything working within days, right? Just as an example, we got it to work in a couple of days, right? Everything with AWS best practices, with infrastructure as code, really awesome, right?
So they also provide the Terraform templates and everything?
Yes, they do have. So they have Terraform templates. They also have CDK templates. So
we can choose. That's really cool. So go have a look. It's data on EKS. It's easy to search on the web. It's on the GitHub AWS Labs repository and contribute as well. Contributing to open source is not only contributing code, but opening an issue or fixing a typo in the documentation. It doesn't have to be to write code. Thank you, Edith, for your very clear explanation of that project about deploying a Jupyter Hub on Amazon EKS. Thank you, Tiffany, for co-hosting this podcast. Thank you for having listened to this episode until the end. See you next week in all good podcast application. But now, go build